and repeat it, and then notice that there is a change in color of the blue litmus paper. So blue litmus paper has been changed to red litmus paper. It means the solution is acidic in nature. So this is an acid. So it is also one property of an acid. Acid solutions conduct electricity. They are electrolytes. So whenever any acid solutions conduct electricity, then we call those solutions are known as electrolytes. So not only acid solutions, bases also conduct electricity. So either acids or bases, we will call them as electrolytes here. So acids are have so-to taste. Acids turns blue litmus to red litmus. Acid solutions conduct electricity. So out of 8, 3 properties of acids we have discussed now, and look at the fourth property of an acid. Acids reacts with metal to form hydrogen gas. So here what happening? So here whenever acids reacts with any metals, basically it reacts with metals and forms a salt, metallic salt, and releases hydrogen gas. So for this we are having an activity as well. So you can see that acid reacts with metal. So here metal plus acid gives rise metallic salt plus hydrogen gas. Reaction for this, instead of metal, so in the place of metal, take zinc, which is in solid state, plus acid, sulfuric acid, H2SO4 aqueous solution. So that is dilute sulfuric acid gives rise ZnSO4, zinc sulfate, aqueous salt, zinc sulfate, a salt, plus hydrogen gas. So here, upward arrow mark represents the liberation of gas. Is it clear? So what are the 4 properties which we have discussed so far? Acids have a so-to taste, acids turns blue litmus to red litmus, acid solutions conduct electricity, and acid reacts with metal to form hydrogen gas. And we'll see an activity to form a hydrogen gas here. Chemical properties of an acid with metal. So reaction of dilute sulfuric acid with zinc metal. Okay. So for that we need a table. On the test table stand here, test tube stand. Fix this test tube here to the stand. This is boiling tube or test tube we can call. And then a probe which consists of soap water in it. And then add some zinc granules to the test tube. You can see here zinc granules, and then add sulfuric acid into it, H2SO4. Okay, dilute sulfuric acid, and then we need to keep a rubber cork of single hole at the top of the mouth of test tube. Okay, and which is a single hole, and then place a delivery tube or a glass tube so that it can immerse into the water to form soap bubbles here. Place the delivery tube here or glass tube so that the gas which is liberating from this reaction, whenever this zinc granules metal pieces reacts with acid, dilute sulfuric acid. Okay, so what happens, these two combines together, and there is a chances to displace ions from dilute H2SO4. Zinc reacts with H2SO4 and displays hydrogen ions, and then it combines with sulfuric, what we call sulfate SO4, to form zinc sulfate. You can see here the gas which is liberating here, glass delivery tube through which it is passing through the soap water, and then bring a burning match stick or a burning candle. So what happens if you bring a burning candle near to this soap bubble or bubbles formed here? So bubbles filled with hydrogen gas, the burns with a pop sound. Hydrogen gas burns with a pop sound, making a little explosion. Okay. So that is an activity to see when hydrochloric acid or sulfuric acid reacts with a metal. That is an fourth property of a acid. Okay. Now we'll discuss the fifth property of an acid, that is when acid reacts with metals carbonates and metal hydrogen carbonate. So here you have seen that in activity property number 4, when acid reacts with metal, which gas is liberating? Hydrogen gas. Am I right? But when acid reacts with instead of metal carbonate, releases carbon dioxide. Which gas gets released? Carbon dioxide. Why? Because here it is, metal carbonates are there. Whenever acid reacts with carbonates, definitely there is a chance of liberating carbon dioxide gas. Is it right? So here acid reacts with metal carbonate and metal hydrogen carbonate to form carbon dioxide gas. You see, acid plus metal carbonates. So metal carbonates plus acid gives rise salt plus carbon dioxide plus water. Is it right? So not only metal carbonate, instead of metal carbonate, if you get metal hydrogen carbonate as well, metal hydrogen carbonate, okay, plus acid, the output, that is products, are same. What are the products? Salt plus carbon dioxide plus water. So no matter what is reacting with acid here, either metal carbonate or metal hydrogen carbonate, the output, that is the products, are same here. Salt plus carbon dioxide plus water. With salt we'll get the same metallic salt. Okay. Now we'll see the example of metal carbonate. So best example for metal carbonate is sodium carbonate. What is the chemical form of sodium carbonate? Na2CO3. Very good. So here metal carbonate plus acid, Na2CO3, sodium carbonate plus acid, that is HCl. Okay, sodium carbonate and HCl, hydrochloric acid, gives rise sodium salt, NaCl. Okay, sodium salt, that is NaCl, sodium chloride plus carbon dioxide, CO2, and water, H2O. So here NaCl is sodium chloride, CO2 is carbon dioxide, and H2O is water. So what are the products? Sodium carbonate reacts with hydrochloric acid, gives rise sodium chloride plus carbon dioxide and water. Is it right? Now, to balance this, Na2CO3, we are having two NAs here, only one Na. So keep two here to balance it. And whereas carbons 1 gets balanced, and oxygens 3 and 3 are balanced, and hydrogen is not balanced. To keep hydrogen 2 on right hand side, so we have to keep 2 on left hand side as well. Is it right? So hydrogen is also balanced and chlorine also gets balanced. Now instead of sodium carbonate, what is the next one? Yeah, take sodium hydrogen carbonate, that is metal hydrogen carbonate. Metal hydrogen carbonate, NaHCO3, reacts with HCl, gives salt plus carbon dioxide plus water. With salt again we are taking sodium carbonate only, sodium hydrogen carbonate. So gives sodium salt, that is NaCl only. Sodium hydrogen carbonates combines with hydrochloric acid, gives NaCl, sodium chloride plus CO2 plus H2O. NaCl is sodium chloride and CO2 is carbon dioxide and H2O is water. Is it clear? Very simple. Hence, the carbon dioxide gas is formed in the form of brisk effusiveness. Is it right? The rapid escape of small bubbles of gas forms the liquids. Okay, you can see here this two points are very important. So this point in the form of the rapid escape of small bubbles of gas to form the liquid here. So the carbon dioxide gas which is coming out of it is very important to us to form milk of magnesia or calcium carbonate here, not milk of magnesia, calcium carbonate. So here carbon dioxide gas which is coming out of it. So what we'll do, we'll pass this carbon dioxide gas over a surface of lime water, over a surface of lime water. Okay, CaOH taken twice, calcium hydroxide. Then it forms calcium carbonate. You see, if the excess of carbon dioxide gas is passed through a lime water, then white precipitate formed first dissolves due to the formation of soluble salt calcium hydrogen carbonate. Okay, and then the solution becomes clear again. So basically, if you take a lime water here, okay, the carbon dioxide gas which is coming out of that reaction, which reaction? The previous reaction, okay, pass over the surface of this lime water. Lime water is calcium hydroxide, okay, CaOH taken twice. And then simply once you pass the carbon dioxide here, it combines with calcium hydroxide, and it forms a milky white solution. You can see here a milky white solution is formed here. When carbon dioxide is passed through a lime water, it turns milky. Okay, if you pass excess amount of carbon dioxide which is more than the required carbon dioxide, okay, if you pass excess amount of carbon dioxide to this solution, again what will happen, it turns to a colorless solution and that dissolves in water completely. If you pass excess amount of water or excess amount of carbon dioxide to this solution, so this solution will turns to colorless. Why? Because if you pass excess amount of carbon dioxide over the surface, this calcium hydrogen carbonate completely dissolves in this solution, dissolves in this, and then forms a clear solution. Here you can see colorless solution. If carbon dioxide is passed for a longer time, the milkiness disappears. Why it gets disappears? Because it's completely dissolves in that solution. Is it clear? The equation: calcium hydroxide, over the surface we are passing carbon dioxide. Is it right? So here calcium hydroxide is there, that is lime water, and we are passing over the surface of this solution, that is carbon dioxide. Then it combines together to form calcium carbonate. Calcium hydroxide plus carbon dioxide gives rise calcium carbonate, CaCO3, white precipitate, plus water. Is it clear? Plus water. Then, if you pass further the calcium carbonate, calcium hydroxide, what we call, if you pass further carbon dioxide gas over the surface, it means calcium carbonate plus water plus CO2 gives rise calcium carbonate combines with carbon dioxide and water to form calcium hydrogen carbonate. Calcium hydrogen carbonate, CaHCO3 taken twice. Okay, calcium hydrogen carbonate soluble in water. So this is our fifth property of an acid. Is it clear? So how many properties we have discussed so far? Five properties. Now look at the sixth property. Acid reacts with base or alkalis. Alkalis in the sense which dissolves in water. The bases which dissolves in water are known as alkalis. To form salt and water here, it is known as a neutralization reaction. Basically, a neutralization reaction takes place when strong acid reacts with a strong base. Is it clear? Gives a neutral salt and water. So here, acid plus base gives rise salt plus water. The example for acid is HCl and example for base is NaOH. So here given reverse here. So NaOH is strong base and HCl is strong acid. Okay, HCl is what? Strong acid, and whereas NaOH is what? Strong base. Both are combining together. Okay, both are combining together to form a normal salt, that is common salt, neutral salt, NaCl, sodium chloride, and water. Is it clear? When sodium hydroxide, that is base, reacts with hydrochloric acid, that is acid, gives rise a sodium chloride, that is neutral salt, and water, H2O. Is it clear? So this is our sixth property. Now seventh property. Acid reacts with metal oxides to form salt and water. Hence, metallic oxides are said to be basic oxides. What are the metallic oxides? They are said to be basic oxides. Always remember, we are having two types of oxides. One is metallic oxides, another is non-metallic oxide. Metallic oxides always behaves like a basic in nature, whereas non-metallic oxides always behaves like an acidic in nature. So metallic oxides, calcium oxide, magnesium oxide, copper oxide, and then sodium oxide, potassium oxide, any oxide. which is metal oxide, always behaves like as a basic in nature. So we call them as basic oxides. But whereas non-metallic oxides like carbon dioxide, is it right? Nitrogen dioxide. So those are acidic in nature. You can see here metal oxide plus acid gives rise salt plus water. So copper oxide, okay, metal oxide combines with HCl to form copper chloride. So here copper 2 represents the valency of copper is 2 here. If copper 3 is there, that is the valency of copper is 3. Okay, and here it is 2. Copper oxide, copper 2 oxide means valency of copper is 2, combines with hydrochloric acid HCl to form copper chloride plus H2O. Copper chloride, what is the valency of chlorine? 1. So how many chlorines required to form a copper chloride here? For 1 copper, 2 chlorines are required. So copper chloride, copper 2 chloride, is it right? Plus water. Okay, sir, why we will write this 2 in the bracket? What is the need of it? Because there is a change in valency of copper. That's why whenever the valency of copper 2 is required, then we'll write in the bracket 2. If 3 is there, means 3. Is it clear? So copper chloride is formed, copper 2 chloride. 2 chloride means valency of copper is 2, and it gives and water as well here. So this is what metallic oxide combines with acid to form salt and water. So here metallic oxide is, what is the nature of the metal oxide? Basic in nature. So one copper, one copper. But whereas hydrogens required 2 here, oxygen 1, oxygen 1. Chlorines also required 2, so to just keep 2 here so that it gets balanced. Is that right? Chlorines also gets balanced here. So 2 HCl. So far, how many properties are over? 7 properties are over. And the last property, acids, shows corrosive nature. Acids have corrosive nature. So how to prove that? You can see this. The mineral acids causes severe burn on the skin and attack to and eat up materials like cloth, wood, metal structures, and stoneworks. So they are said to be corrosive. Is it clear? Basically, acids eat the following materials like cloth, wood, metal structures, and stoneworks, etc. So that's why you call them as they are corrosive in nature. So how many properties of acids are over now? 8 properties. What are those? Let me recall these all. First property of acid is acids have so-to taste. Acids turns blue litmus to red litmus. Acid solutions conduct electricity. Acid reacts with metals to form hydrogen gas. Acid reacts with metal carbonate and metal hydrogen carbonate to form carbon dioxide. Acid reacts with bases or alkalis to form salt and water, is also known as neutralization reaction. Acid reacts with metal oxides to form salt and water. Here metal oxides are basic in nature or basic oxides. Acids have corrosive nature. Acids have corrosive nature. Is it clear? So these are the 8 properties of acids. Now we'll see how hydronium ions forms. Okay. So first of all, to form hydronium ions, hydronium means H3O plus ions. Hydronium means H3O plus ions. To form H3O plus ions, we need HCl and just dilute into water, and then you'll get H plus ions. And then that H plus ions, if you add into water, then you will get H3O plus ions. We'll see here. What do all acids have in common? See, acid HCl. Whenever you mix with water, both ions get separate, H plus ions and Cl minus ions. You can see here it is gets diluting and it separates H plus ions and Cl minus ions. Like that, all HCls get separated into H plus and Cl minus ions. Okay, is it clear? You can see here. HCl aqueous gives rise H plus aqua plus and Cl minus aqueous. It means H plus ions are get separated and Cl minus ions are get separated when mixed with water. Separation of H plus and HCl minus ions will be possible in the presence of water. This process is termed as ionization. Okay, what is ionization? The process of separation of H plus ions and Cl minus ions in the presence of water. So this process is known as ionization. Okay, and we are having different ionization energies. First ionization energy and second ionization energy. That is different topic. And here now which is obtained here H plus ions. If you add to water and then you will get H3O plus ions. Those are hydronium ions. What are hydronium ions? H3O plus ions are known as hydronium ions. So this happens because H plus ions are not stable. Clear? To investigate whether all the compounds containing hydrogens are acids. No. So we have an activity that and glucose and as well as acids. You can see here the aqueous solutions of an acids conduct electricity due to the presence of charged particles called ions in it. So here in the case 1, dilute HCl, the bulb is glowing, whereas in case 2, glucose solution, bulb does not glow. Because dilute HCl solution contains H plus ions, whereas glucose solution does not contains positively charged particles. Is it right? So here no charged particles in glucose, but whereas in HCl charged particles are there. That's why bulb glows in HCl, whereas bulb does not glows in glucose solution. Is it clear? So it is also very important. So here is the question: to does the solution which contains all hydrogen ions all are acids? Means no. So here glucose also contains hydrogen, so it means it is not an acid here, and it does not conduct electricity as well. Okay, so here you can say that from this experiment we conclude that the hydrogen contains compounds such as glucose and alcohols are not acid because they do not dissociate in water to produce H plus ions. Is it clear? But acids dissociate H plus ions, okay, in water so that they conduct electricity here easily. Acids do not show acidic behavior in the absence of water. It means here is an activity when dry HCl gas comes out of this. So what happens if you are having dry litmus papers, there is no change in color of the litmus paper. But if you get wet litmus paper, it shows its acidic nature. We'll see that activity as well. In the absence of water, a substance will not form hydrogen ions and hence will not show its acidic behavior. So if you have dry HCl gas, take 0.5 grams of copper chloride, salt CuCl2 in a test tube and add to it a few drops of concentrated sulfuric acid H2SO4. The test the gas evolved with wet and dry litmus paper. Okay. So what we are doing here, copper chloride CuCl2, we are combining with a sulfuric acid to form HCl. Okay, how the HCl gas forms here? You see, this is what test tube which contains concentrated H2SO4. Now we are adding copper chloride into it. Okay, even we are having a rubber cork with one hole. Bent tube is there here, and here are the zinc granules. Copper chloride is there, not zinc granule here. Copper chloride is added into this test tube. Okay, now if you close it, the reaction takes place in between these two and then liberates a gas from it. Okay, copper chloride CuCl2 solid in state combines with H2SO4 aqueous solution, okay, to give copper sulfate plus HCl. CuSO4 copper sulfate plus 2HCl gas. Okay. Now it is not an aqueous solution, it is a gas solution. Gas, not a solution. Is it right? So whether it shows acidic nature or not, we have to test with wet litmus paper and dry litmus paper. Wet means which is contains some moisture on the surface of the paper, and dry means which is completely dry. Is it right? So here, just keep a dry litmus paper. HCl gas is coming out of this test tube. Okay. Then dry litmus paper, blue litmus paper. Why only blue? Because HCl is acid in nature, so red remains red only. So if we test with blue litmus paper, then we can identify whether it is showing the acidic nature or not. So here it is, dry litmus paper. Is there any change in color of the paper? No, no change in color. It means what? That hydrochloric acid gas is not showing its acidic nature in the absence of what? Water. Now change the dry litmus paper to moisture paper. Moisture litmus means litmus, Litmus. Here it is, L is missing. So if you observe, is there any change in color? Notice here. Yes, there is a change in color of the paper. Why? Because some moisture is present on the surface of the litmus paper. So that's why it is showing that acidic nature here. Is it clear? So hydrochloric acid is formed here, which is dry acid. Dry gas is reacted with your moisture paper, and it showed its acidic nature here. Is it clear? And in the next class, we'll discuss about the properties of bases. Is it clear? So far, we have discussed properties of acids, okay, and how to form hydronium ions, and then whether the dry HCl shows its acidic nature or not. So to show acidic nature, which paper is required here? Moist litmus paper, but not dry litmus paper. Is it clear? So let me stop the session for today here, and we'll continue in the next session with properties of bases.